Did the Webb telescope find alien life on exoplanet K2-18b? Here's what we know. The research claims of biosignature gas detection were premature. Recent reports of NASA's James Webb Space Telescope finding signs of life on a distant planet understandably sparked excitement. A new study challenges this finding, but also outlines how the telescope might verify the presence of the life-produced gas. The UC Riverside study, published in the Astrophysical Journal Letters, may be a disappointment to extraterrestrial enthusiasts, but does not rule out the near-future possibility of discovery. And the evidence of life on K2-18b. In 2023, there were tantalizing reports of a biosignature gas in the atmosphere of planet K2-18b, which seemed to have several conditions that would make life possible. Many exoplanets, meaning planets orbiting other stars, are not easily comparable to Earth. Their temperatures, atmospheres, and climates make it hard to imagine Earth-type life on them. But unique conditions on K2-18b, it's different. This planet gets almost the same amount of solar radiation as Earth, and if atmosphere is removed as a factor, K2-18b has a temperature close to Earth's, which is also an ideal situation in which to find life, said UCR project scientist and paper author Shang-Min Tsai. K2-18b's atmosphere is mainly hydrogen, unlike our nitrogen-based atmosphere, but there was speculation that K2-18b has water oceans like our Earth. That makes K2-18b a potentially Hycean world, which means a combination of hydrogen atmosphere and water oceans. Last year, a Cambridge team revealed methane and carbon dioxide in the atmosphere of K2-18b using James Webb Space Telescope and other elements that could point to signs of life. What was icing on the cake in terms of the search for life is that last year these researchers reported a tentative detection of dimethyl sulfate, or DMS, in the atmosphere of that planet, which is produced by ocean phytoplankton on Earth, Tsai said. DMS is the main source of airborne sulfur on our planet and may be playing a role in cloud formation. Challenges in detecting DMS. Because the telescope data were inconclusive, the UCR researchers wanted to understand whether enough DMS could accumulate to detectable levels on K2-18b, which is about 120 light years away from our Earth. As with any planet that far away, obtaining physical samples of atmospheric chemicals is impossible. The DMS signal from Webb telescope was not very strong and only showed up in certain ways when analyzing the data, Tsai said. We wanted to know if we could be sure of what seemed like a hint about DMS. And based on computer models that account for the physics and chemistry of DMS, as well as a hydrogen-based atmosphere, the researchers found that it's unlikely the data show the presence of DMS. The signal strongly overlaps with methane, and we think that picking out DMS from methane is beyond this instrument's capability, Tsai said. However, the researchers believe it's possible for DMS to accumulate in detectable levels, and for that to happen, plankton or some other life forms would have to produce 20 times more DMS than is present on our Earth. Detecting life on exoplanets is a daunting task given their distance from Earth. To find DMS, the Webb telescope would need to use an instrument better able to detect infrared wavelengths in the atmosphere than the one used last year. Fortunately, the telescope will use such an instrument later this year, revealing definitively whether DMS exists on K2-18b. The perspectives on exoplanet research. The best biosignatures on an exoplanet may differ significantly from those we found most abundant on Earth today. On a planet with a hydrogen-rich atmosphere, we may be more likely to find DMS made by life instead of oxygen made by plants and bacteria as on Earth, said UCR's astrobiologist Eddie Schweiterman, a senior author of the study. And given the complexities of searching far-flung planets for signs of life, some wonder about the researchers' continued motivations. Why do we keep exploring the cosmos for signs of life? Imagine you're coming in Joshua Tree at night, in the state park in the United States, and you hear something. Your instinct is to shine a light to see what's out there. That's what we're doing too, in a way, Tsai said. And this is from Biogenetic Sulfur Gases Biosignatures on Temperate Sub-Neptune Water Worlds by Shang-Min Tsai in the Astrophysical Journal Letters. And this is on SciTech Daily by University of California, Riverside. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.